Hey there, it's Irina Nik from Tech Foundation, and today we are going to talk about artificial intelligence and its impact on design. We are going to learn how it will impact the design and how you can already start using artificial intelligence in your design process. We are also going to learn technical aspects of artificial intelligence, because artificial intelligence is not only the generative images or text that we have seen a lot in the last year, but actually it's much bigger and you can do much more with it. So today we are going to learn what types of artificial intelligence are there and how all of them will impact design in the future. So there are different terms going around in media: artificial intelligence, machine learning, and deep learning. So are they the same or are they different? Deep learning is a subset of artificial intelligence and machine learning that is using multi-layered neural networks. And it appeared quite recently, and all the artificial intelligence models that we are going to discuss in this episode are going to be neural networks. So they are actually deep learning models, but as long as we are not engineers here and we just want to understand how it all works, I'm going to use the term artificial intelligence, machine learning, and deep learning interchangeably. But just keep in mind that they are not exactly the same. So if artificial intelligence is quite an old concept, why everybody is talking about it only now? Why it is starting to develop so fast in the recent year? So there are several reasons for that. First, we have accumulated a big amount of data that was never available before. And now machines have much more data to learn from. And another reason is that neural networks have emerged. As we've discussed, there are several types of artificial intelligence, and the previous generation of AI stopped growing after some amount of data. So no matter how much data you feed a traditional artificial intelligence, it will not develop further. Unlike neural networks, so when neural networks have emerged, they managed to develop significantly with a bigger amount of data. If you type machine learning classification on Google, you would probably find supervised, unsupervised, and reinforcement learning. We are going to learn about them, but we are also going to take a look at another model, which is transformers, because almost all the generative AI like DALL-E, Midjourney, or GPT, they are all transformers. And it seems like these transformers have taken all the information space in the recent year. But to this day, actually the most common type of machine learning is supervised learning. Supervised learning use labeled data, so all the data that you feed to the model is labeled. For example, I have a picture and I have a label to the picture. For example, I have a picture of a dog and I label it as a dog. And I feed a lot of pictures to the model that is labeled as dogs, and then I feed another pictures to this model, for example, that are labeled as cats. And as the result, my machine learning model will be able to differentiate dogs from cats. This learning model maps input A to output B. For example, it maps your playlist, different types of music, to the output B, which will be similar music. Or for example, you can input audio as the data and get an output as the text. Or you can input the traffic information, for example, and get an output as the traffic prediction. Or you can feed the algorithm the stock prices over time and get the predictions over the future stock prices. It learns to take input A and get an output B. It cannot take any different input. For example, if your model eats images of cats and dogs, it cannot eat any other images because it will not be able to make sense of it. If your model eats for example, music, different types of music playlist, it cannot eat an essay, for example. And same with output B, it cannot produce any other output. For example, ChatGPT can produce quite different outputs, but supervised learning models, they are trained to produce only one output. For example, an identity detection model is able only to differentiate yourself from anyone else, or a spam detection model is able only to differentiate spam letters from normal letters. Or stock price advisor will be able only to forecast stock prices. So only one type of output B and only one type of input A. There are two types of machine learning algorithms. The first one is classification. As you might guess from the name, it classifies objects. This model takes labeled input and puts it into clusters that you have defined beforehand. For example, the model that recognizes handwritten text was trained on the data that is labeled as symbols. So to make this model recognize different symbols, we have to give it different pictures of these symbols and let the model know which symbol it is. For example, we have many different pictures of a number 1. And then we have also many different pictures of number 2 and so on. So we label all these pictures and we feed it to the algorithm. When the model is trained, it is able to take an unlabeled picture, for example, number 1, and give an output itself, because it has seen a lot of symbols before, so now the trained model can actually tell you what symbol it is. Or, for example, spam detection is also a supervised learning algorithm. It was trained on different types of letters, and some letters were labeled as a normal letter and some letters were labeled as spam. Actually, when you label your letter as spam in your email, it also goes to this spam detection algorithm. So it learns, okay, these types of letter that consist of these words are most likely to be spam. The second type of supervised learning algorithm is regression. This model forecasts an output based on input data. For example, this type of algorithm is able to detect a home price. If we have an input data of local home prices of different houses of different size, and we feed all this data to the model, then when we input a new home, for example, of a particular size in a particular city, this model will be able to detect how much it might cost based on the previous information that it was trained on. The next type of machine learning is unsupervised learning. So these models take unlabeled data as an input. So they are not able anymore to forecast or to classify objects because they don't know the label. But what they can do is to define patterns. And this is also quite powerful because we as humans are not always able to define patterns, to see the patterns, especially on big data. It's just too much for us, but it is manageable to the machine learning algorithms. As you can see on the picture now, you can train your model on unlabeled data, and this model will be able to define patterns. So in this picture, the model defined different clusters of data. Although we haven't told the model that there are different clusters, but it was able to define them. This can be used for customer segmentations, for example, or to detect patterns in DNA, or to produce recommendations. So it is used in the recommendation systems. It is also used in generative AI. So generative AI is trained on unlabeled data, and usually then it is fine-tuned on labeled data, so it is a transformer. It's not exactly unsupervised learning, but it definitely takes part of unsupervised learning. Let's have a simple example of supervised and unsupervised learning. In supervised learning, you might teach your algorithm to identify an apple, and you train your model on different types of apple images, and you always tell your model that, okay, this is apple. And when you train your model and then you give your model another image of another apple, it will be able to define that this is apple or this is not apple. In the case of unsupervised learning, you don't tell your model that this is apple. Actually, you just feed a lot of images of different fruits or whatever to your model, and your model will be able to cluster these images. So it will be able to understand that these images look similar and these images look a little bit different. So it will be able to cluster images of apples, images of bananas, or images of apricots, for example. So it will never be able to tell you that this is an apple, but it will be able to differentiate different types of fruits, for example, by itself. So you don't have to tell this model that there are different types of fruit. It will understand it itself, and it will cluster different types of fruits by itself. And that's how we come to transformers model. Most of the generative AI models that we will discuss today are going to be transformers. In fact, GPT is an abbreviation that means Generative Pre-trained Transformer, so it is a transformer model. As I've said earlier, it usually trains on unlabeled data, so it uses unsupervised learning, and then it is fine-tuned by the labeled data. This model is able to understand relationships between elements. That's why it is able to make sense of the text that you input, for example, in ChatGPT, because it is able to understand the relationship between words and understand the whole sequence. And that's why it can also produce different outputs, because it is able to assemble the sequence of data itself. And the last type of machine learning algorithm that we are going to learn today is reinforcement learning. And in my opinion, it is one of the most fun algorithms to watch, because you can actually see how it learns. It learns through trial and error. So you give this model a goal, for example, learn how to walk, and it is trying to achieve this goal through trial and error. So for example, if you have a humanoid model, the algorithm will try to make it walk until it succeeds. Let's recap what we've learned. We have different types of machine learning. Supervised learning, they are learning that is trained on labeled data. Unsupervised learning, that is trained on unlabeled data and is able to identify patterns itself. Reinforcement learning, the learning that is used in robotics and games through trial and error. And transformers, it is the learning model that is used for generative AI. All these machine learning types are called narrow AI, and this is because they are able to do only one task. So they are trained to do only one task. If your learning model is able to identify pedestrians and traffic lights, for example, in the autopilot, it will never be able to come up with a new recipe of pizza, for example. Let's review what narrow AI can and cannot do. It certainly can forecast, analyze, and memorize data. It can choose the best item, recommend a new item. It can detect objects, detect pedestrians, traffic lights, differentiate cats from dogs. It can produce the result similar to the data that it was trained on. If we trained our model, for example, on different music from Beatles, it will be able to produce music similar to the Beatles' music. If we fed Mozart, it probably would be able to produce music similar to Mozart music. And now we can see that this starts to shift a little bit. So the results that creative AI produces are quite creative. And this is because of just a big, enormous amount of data that it is trained on. So Midjourney, for example, was trained on enormous amount of images and I think arts from ArtStation also. That's why its results remind more of digital art and they are more artistic, let's say. Same with ChatGPT. It was trained on enormous amount of text data, on code, on essays, on scripts, on letters, everything. And it actually can understand what is letter, what is a text message, what is a play script, for example. So it has seen so much information that it is able to produce almost original, authentic result. So we could say that now generative AI is able to produce more creative result, something that was not seen before, although it was just about the amount of data that it was trained on. And what narrow AI still cannot do? It cannot perform another task. So if we have an algorithm that is able to detect pedestrians and traffic lights, it will never be able to come up with a new recipe for pizza, for example. If we train algorithm to give us a text result, it will never be able to detect pedestrians. And this is how we define actually narrow AI. Artificial intelligence is also not able to learn on small amount of data. For example, if you want to train your algorithm to forecast stock prices, for example, it's not possible to give just few examples and train your algorithm on just like a small data set. The results from this model will not be reliable. So this is a very big limitation. People sometimes can understand the concept, can understand the meaning when they are given just few examples. But this is not how artificial intelligence works. To make artificial intelligence work, you need to give it enormous amount of data. Although now with pre-trained models, we can also say that it starts to shift a little bit. Pre-trained models were trained on big data, but then they can be fine-tuned on much smaller amount of data. GPT, for example, is pre-trained model that anybody can fine-tune to their needs. For example, you can fine-tune GPT to use it for your customer support chatbot. To do this, you need to feed the machine few thousand examples of the real conversations. Or GPT can be fine-tuned to understand the sentiments. To do that, you need labeled examples of positive and negative sentences. Usertesting.com, for example, is doing that to automatically identify where users struggle during the test session. What it also cannot do yet is kill all humans. So all the apocalyptic scenarios are not possible yet because artificial intelligence is not smart enough to do so. They cannot go beyond their task. So if their task wasn't kill all humans, it will not be able to do so. What are the other limitations of artificial intelligence? Artificial intelligence is often biased, and this is because it is trained usually on biased data. And the data is biased because we humans are biased. So for example, if our algorithm was trained to detect an eye blink, and it was trained by European engineers who trained an algorithm on European images of eyes. This algorithm might easily fail on other type of eyes, for example, on Asian eyes. And this is actually what happened with Canon. Same with text. A lot of our text data is also biased. For example, a lot of literature has male characters and very few female characters. So when we feed this literature to the algorithm, it learns that male characters are more common, so this is what it will produce. Same with justice. There were experiments that were trying to implement artificial intelligence in the justice system because it was thought that artificial intelligence can be unbiased in their decision and can predict if the person is guilty or not with more confidence that humans can do. But it turned out that even our information about crimes is also biased. For example, it is biased towards Black people. Black people are put to jail more often, and when we train the algorithm on this data, it learns to become biased towards Black people. So this is something that we have to be very cautious about. Our world is biased. We as humans are fighting this bias, but our algorithms are yet stupid enough just to take this bias and reproduce it. So one of the biggest problems with artificial intelligence that it can easily produce biased results. Another problem is unethical and dangerous results. Artificial intelligence can easily learn how to make a bomb. Artificial intelligence can easily learn how to insult people. For example, there were experiments with the Twitter chatbot by Microsoft. So they've launched the chatbot several years ago that would learn on different tweets from people. What would you think? Just in one day, this chatbot learned to become racist, learned to insult people. They had to shut down the project just after one day. And this is why many people were not so cautious about OpenAI technology, because many believed that it's just at this point of time, it's not possible to get rid of unethical and dangerous and biased results from artificial intelligence because we just don't have this clean data. But OpenAI has managed to teach its models to be ethical by unethically employing low-paid workers from poor countries that had to manually go through inappropriate and dangerous content and flag it accordingly. This data was used to train another AI that prepares the training data for GPT and cleans it from toxic content. Artificial intelligence can also easily produce incorrect or misleading information. And I'm talking about large language models in particular because this is where artificial intelligence is actually able to invent new concepts that never existed before actually. Because as we've discussed, these models are able to understand the relationships between elements to make sense of it. But they don't have the understanding of truth and lie. They don't have the understanding of something that exists in the world and something that doesn't. They just able to make words look like this text has meaning, and sometimes it might be dangerous. And I think if Microsoft actually invests $10 billion in OpenAI, that's where much of this money will come to fight bias, to teach AI to differentiate truth from lie, to teach AI to give only ethical results. And that's when we come to general artificial intelligence. So general AI or strong AI is the concept of artificial intelligence that is able to produce any human intelligence task. So this is a vision of the future of artificial intelligence that is actually very like human. So this artificial intelligence has self-awareness, or it is able to do something that it wasn't taught to do. Until this day, it's still the future concept. But looking at ChatGPT, for example, and looking at how much bigger GPT-4 will be, I think we are coming closer to general AI, and we have to be aware of it. So this general AI will definitely take much more jobs than any other artificial intelligence algorithm. So we have to be cautious about it. And if you think that AI revolution or fourth industrial revolution is the concept from futuristic movies, you might be wrong, because it is actually that is happening already now. 34% of businesses across US, China, and Europe already implementing some sort of artificial intelligence. And it's not always ChatGPT or text-to-image generation. Actually, this is something that just emerged. So almost no one has incorporated generative AI in their process, but this 34% stands for other types of artificial intelligence that we have discussed today. Many organizations like World Economic Forum or IBM recognize that artificial intelligence will be the main technology that will drive fourth industrial revolution. This video was quite long, so I have decided to break it into two parts. The first part was about technical aspects of artificial intelligence that enabled you to actually understand what it is and what it's capable on. And the second part will be on the impact of artificial intelligence on our world and on design in particular. If you want to be ready for the world that is coming, make sure you watch also the next video that I will leave in the description below. Don't forget to like this video and subscribe to the channel, because here you could find a lot of relevant and free information for designers.